Robotic systems in laboratories are on the rise. This is also the case at the Fraunhofer Institute for Silicate Research in Würzburg. Here, a robot has recently been able to carry out the synthesis of nanoparticles completely automatically. It was developed by the researchers in collaboration with Goldfuß Engineering. We integrated 10 laboratory devices mechanically and electrically for fully automated operation. The robot can handle everything individually, and the software takes care of more than a dozen individual process steps in the production of nanoparticles. There were minor stumbling blocks during the development. The biggest challenge was actually translating the manual steps into automated steps. This is because the robot cannot perform some tasks one-to-one in the same way as a human. One example, unscrewing bottles. For us humans, it is a totally simple task to unscrew and open a bottle. The robot cannot do this, even though it has two gripper arms. Our project partner developed and built a special module for this purpose so that the robot can also open bottles. Currently, we can carry out the synthesis completely with this system, starting with the metering of the reactants to the purification of the finished product. But this system is particularly interesting for taking over routine tasks that cost an extremely large amount of time. To find out how efficiently and in what quality the robot performs the required steps, the researchers had it compete against laboratory employees. Our findings in the case study were that the robot can make syntheses with higher reproducibility. This is particularly striking when we compare different people. If an employee does syntheses regularly, then, over time, he or she can really repeat them very reproducibly. But if we have staff changes in this work, then you can already see extreme differences. The robot does everything in the same way. While the robot cleans up particles, the employee can devote himself to other tasks. The modular design of the system is not only advantageous for this project, but can also be integrated into future processes. We have solved individual substeps such as centrifuging, mixing, and weighing to our satisfaction, and can of course use this for all other laboratory systems in the future. This means that validation is simpler. For example, according to GMP, and verification is of course just as easy. For us, this means that we naturally have a highly flexible automation level where we can then compile the individual processes again and again. We have a lot of plans for this system. We would like to equip this system with further modules and then also produce different material systems. The second point is interesting and extremely important. We not only want to produce particles, but also characterize them. In other words, we would like to introduce new modules that also enable automated analysis of nanoparticles. And of course, it is also very interesting, also later, not only to produce nanoparticles reproducibly, but also to optimize the synthesis. In this case, we would like to combine our equipment or robots with artificial intelligence in the future, for example, so that we can also improve the parameters during synthesis.